This is Brilliant's course on multivariable functions, and it's just the introduction where they teach you some linear algebra so that you can do calculus in, well, I don't know if we're going to get that far, but so that you can start thinking about functions on spaces. And this is how they introduce the cross product. How to multiply two vectors in R3. How to cross two vectors together. It relies on the 3x3 determinant and its properties. Basically, the determinant gives you this volume in a three-dimensional space. And then they start talking about linear combinations and linear independence of the three vectors. And they ask you to prove that if the three vectors aren't linearly dependent, that the determinant is zero. In other words, this volume vanishes. And if you look at the explanation of why the determinant is zero, I'm sorry, I can't save this because the way Brilliant works, it renders pages on the fly, and I guess they don't want you to save the HTML. If I go to the browser and say save page as, the resulting page won't display, and I guess it's because they don't want people to save copies of this, because it's a paid you can only get this if you pay, and they don't want people to steal their money. So they start with the definition of a determinant of that matrix A. That's all right. This is the old. It's plus minus plus minus plus minus plus minus plus, and then you take the minor of whatever the entry is that you're putting here. But for the top row, which is usually the only one anybody remembers, it's plus minus plus and these. And now you're rewriting A1 as a linear combination of B1 and C1, and A2 is the same linear combination of B2 and C2, and A3 is the same linear combination of B3 and C3. So the vector A is a linear combination of the vectors B and C. And this is their explanation. So you start with a definition, you multiply out, and you get this thing. And then you can multiply out a little bit further if you want, but these are just it's just taking the factor out of the first level. So you can factor out S and T, and that's all they've done. And then they say this is zero. This whole thing in here is zero, and this whole thing in here is zero. That's the explanation. So you ask yourself, why is this whole thing in here zero? Is that really all you need to say to prove that that's zero? Because I tell you what, if B and C are not linearly independent, what happens? And if they are linearly independent, Why are they zero? What is it? What goes on? Why is that an explanation? I'm only asking because I think a student would ask that. And now we get here and we do this thing where you pretend I guess you pretend you don't know what you're. I don't know what this punning of the where you're replacing these are also normal vectors, and you're taking the determinant, you're just using the shape, but these are the wrong types of quantities in here. We're on the face of it looking for scalars because these things are multiples, but yeah, that doesn't matter. That's not what I call teaching. I'm really sorry. It's really shoddy teaching. And yeah, the students can get through it. They just learn, just remember the stuff. Don't try and understand it. And since it's actually true, and you can prove this in other ways, but we're not going to be told here how to do that. It doesn't matter. But I don't think that's the right way to teach maths. That's not intuitive. To see a quantity like that and deduce that this thing here is zero is that's not how maths works for me.